Today, we are in our day 3 of e-FDP program organized by Seven Hills College of Pharmacy in association with APTI Andhra Pradesh. And on the screen today, we have four dignitaries. The one, our beloved principal sir, Dr. M. Niranjan Babu, and today's chief guest, Professor R. Ravindra sir from RR College of Pharmacy, Bangalore, and today's expert speaker, Dr. Muralidhara from GEM. So he's a statistic academician from GEM and academic ambassador too. So I welcome you all to this day 3 of e-FDP program, sir. I hope you will be up to valedictory function. And now I request our principal, Dr. Niranjan Babu sir, to give a welcome note. Sir, over to you.
Om Namo Venkateshaya. Namaste. Good morning. On behalf of Seven Hills College of Pharmacy, I welcome Chief Guest, Professor R. Ravindra, RR College of Pharmacy, Bangalore, Karnataka, Dr. K. Bhaskar Reddy, Director, Sri Venkateshwara Institutions, Chittoor, Andhra Pradesh, Speaker, Dr. Muralidhara Anandamurthy Garu, Academic Ambassador, JMP Group, SAS Division, Bangalore, all the principals, teachers, registered delegates, welcome to this third FDP day. I hope that everyone would take the results of this program. I am confident that your valuable ideas will prove useful to overcome new challenges and define a new dimension in dealing with the situation of COVID-19. I wish success of this FDP through this webinar. Have a nice day. Jai Hind.
Thank you, sir. Thank you for your valuable wishes. And now it's my privilege to introduce our today's chief guest, Professor R. Ravindra sir, to our teaching fraternity. Professor R. Ravindra sir, he is from RI College of Pharmacy and currently holds a position of HOD in pharmacochemistry. And truly, he is a senior professional and educationalist and a good administrator in RR College of Pharmacy. During his tenure, Sir held various positions which are challenging towards the administration and also towards the academics. And his excellency to impart a quality education in pharmacy is truly amazing. Sir have various functional experiences like it take parts in organizational skills, conduct a lot of training and development programs, and still today sir is a crucial person and playing a vital role in RR College of Pharmacy to impart. And because I'm receiving a lot of messages from RR College of Pharmacy, which is organized by Professor R. Ravindra sir. Thank you, sir. And also, sir has published a lot of papers in peer-reviewed journals, which are almost 30 to 40 in number. Sir have various academic accomplishments like examiners and council member, and he have a lot of credentials in District Chairman of Lines International and also an inspector of Pharmacy Council of India. Sir, it's truly amazing for accepting our invitation, and I sincerely thank for inviting and presenting to this third day of e-FDP. Sir, it's over to you. Kindly give your best wishes for our e-FDP program. Thank you, sir. Ravindra, sir. Sir, Ravindra, sir, am I audible, sir? Ravindra, sir.
Madam Sucharita, I think he's having, connectivity problem.
Okay, sir. Okay. Can we go further, sir?
So later stages, he may join with us and he will wish us. So
okay,
meantime,
sir.
you can proceed, I think.
Yeah, okay, sir. Okay, sir. Thank you, sir. Thank you. And now I request my colleague, Mrs. Divya Madam, to introduce our today's expert member, Dr. Muralidharan, sir, from SAS Ambassador from GEM. So, Madam, please take this opportunity to introduce our today's speaker to the teaching fraternity. Madam, it's over to you.
Good morning to everyone. Good morning, sir. Our beloved Principal Dr. M. Niranjan Babu Garu, our today's chief guest, Professor Ravindra sir, and today's expert Muralidhara sir. I am Divya, Department of Pharmaceutics. I take privilege to give a short note on to Mr. Muralidhara sir, today's expert. Mr. Muralidhara is part of JMP Global Academic Team and collaborates with professors and universities for statistical and analytical excellence. He holds a BTech from Bangalore University, MBA and PhD from Vishveshwaraya Technological University, and he has served more than 15 years in the analytical industry and worked for Genpact, Target, and Danske, holding good positions. And he continues to learn and share in the area of analytics, data science, and statistical thinking. He currently works as an academic ambassador for Global Academic Team of JMP, where his role is to orchestrate the statistical and analytical thinking by collaborating with universities. And JMP is a statistical discovery from SAS for engineers, scientists, and leaders. Welcome, sir, and I take privilege and for getting our great expert as a speaker today. Thank you, sir. Thank you, everyone.
Thank you so much.
Thank you, sir.
I request now Dr. Muralidhara sir to take over the session and please give your valuable words to our teaching fraternity. Sir, it's over to you. You can share.
Thank you so much, madam. Namaste and good morning, everyone. Yeah, I want to
Just
share
a
my
minute.
screen.
Good morning.
Yeah.
Sir, Ravindra sir. Ravindra sir, am I audible to you, sir? Sir, Niranjan sir, Ravindra sir was in line, sir. We can try to contact him, sir. Was in line.
Yeah. Ask him to wish.
Sir, Ravindra sir. Hello. Hello. Maybe again connectivity issues, sir. So, Murali sir, you can go ahead.
Okay, thank you so much. Yeah. So, namaste and good morning. Thanks, Professor, for the generous introduction. Let me share my screen. So, hopefully, you can all see my screen. So, thanks to all the participants, professors, researchers, and students for spending your quality time in the morning, that on a Sunday morning. Also, thank management and professors of Seven Hills College of Pharmacy for giving me this wonderful opportunity to present and share. As I said, I'm part of a global academic division of JMP, JUMP division of SAS. It's pronounced as JUMP. So even though it's JMP, it is pronounced as JUMP. So I keep telling JUMP, JUMP, JUMP. It's actually JMP. Okay. So here is my presentation plan for today. Quickly, I'll talk about what is JUMP. I also know that some of you have already downloaded the software. If not, please feel free to download and explore because there's a 30-day free trial. Download from jump.com. And how JUMP software is enabling breakthrough discoveries across industries and as well as research and academics. So that will be followed by statistical thinking or discovery through JUMP. And I'll be demonstrating the power of JMP JUMP statistical discovery software using a tablet production data. So that's closer to the pharmacy, if I believe. So I will also focus on design of experiments and show you a simple mixture design using custom design platform. Okay, that's the plan for today. JUMP is a statistical discovery tool from SAS. SAS, as all of you know, is the #1 company in statistical data analysis, analytics, data science, machine learning, etc. SAS continues to create value for its customer through analytics since from last 42 years. JUMP is a part of SAS and is a tool of choice for scientists, engineers, and other data explorers across the world from last 32 years. JUMP is interactive, visual, graphical user interface, that means GUI based, and it's desktop based. That means both on your Windows and Mac, and it's a powerful statistical data analysis software. The word discovery is very important because JUMP is designed in such a way that it's dynamic linking and easy to use. Powerful statistical algorithms help the data explorers to unearth the insights and make breakthrough discoveries from data and experiment. So it enables the researchers to perform quickly, and that's the reason it's called statistical discovery from SAS. JUMP. Okay, JUMP has three powerful solutions. The JUMP Pro focuses on statistics, visualization, predictive modeling, machine learning, design of experiments, which is the unsung hero of analytics, quality, Six Sigma, survival, reliability, consumer and market research, essentially everything you use for research and teaching in informatics department. JUMP Clinical focuses on clinical data analysis, ensuring trial safety, efficacy, role-based workflows, reusable templates, and automated reporting tools make it easy for all the key participants in the trial review process to explore trends and outliers and share results. Some of the capabilities include research-based oncology visualization, risk-based monitoring, data monitoring, and statistical analysis. JUMP Genomics focuses on advanced genomic data analysis that helps you to visualize your data and discover more, whether you are working on pharmacogenomics, biotechnology, or any other area related to genomic research. It helps you to analyze rare and common variants, detect differential expression patterns, find signals in next generation sequencing data, discover reliable biomarker profiles, and visualize patterns through integrated genomics data analytics software. So I'll be using JUMP Pro in today's demonstration. Please feel free to connect with me if you want to know about any of these in detail. Okay, so please feel free to connect with me. So as I said, JUMP continues to create value for its customers across the globe. Some of the industries and the companies are, look at the chemistry, BASF, Dow Chemicals, Nomer, Simrise, etc. When it comes to life sciences, Merck, AstraZeneca, NNE, Pharmaplan, Ono Pharmaceutical, Lispen, I can go on and go on. I think pharmacy, Meditox, Mitsubishi Pharma, so I can go on the list, including the Indian companies as well. So they've been using JUMP from last couple of decades. It's also used in manufacturing, retail, etc. So it's been a great tool for industry as well. So if you look at the academic perspective, from an academic perspective, close to 600 plus universities or departments across the globe are using JUMP for teaching and research from last couple of decades. It could be in United States, Europe, Australia, Asia. The teaching or the research areas include science, pharmacy, chemistry, engineering, and other departments. Here is a list of courses which are taught using JUMP. Specific to pharmacy, something stands out as basic statistics, biostatistics, simple t-test, ANOVAs, regression, multivariate, design of experiments, quality by design, predictive modeling, etc. I can go on and go on. This year we started a JUMP academic program in India, through which we are proposing unlimited license of JUMP software for academic adoption. So just after this, if you feel free, if you want your institute to get unlimited licenses, feel free to connect with me, and we can get you JUMP for your institute for academic adoption and research. Okay, let's jump into statistical discovery, the essence of today's discussion. Here is an example of tablet production. Okay, I'll just give you the process a little more, and then we'll take the data set and then I'll start analyzing it. This picture represents a process map of the production. It is a secondary drug process that involves milling of an active pharmaceutical ingredient API into a powder of uniform particle size. The milled material is then blended with other ingredients to bulk up and evenly distribute the API. That's the milling. This blended material is then compressed into tablets, which are finally coated to aid shelf life, taste, and other properties. That's the compression. At the end of the process, a dissolution test is performed. Dissolution is so critical in pharmacy, right? And if the average dissolution value of several tablets is less than 70%, dissolved at 120 minutes, the tablet batch is rejected. This is a simple process. We'll take this example and let's go to the discovery mode. Okay, so we need to put now data to discovery. This is what you have a data and you want to discover something and make patterns and get into the action. So here is our journey from data to discovery. First, let's visualize the data, power of visualization. Then descriptive and inferential understanding, a bit more of multivariate analysis, and build a model. Post that, let's fine tune the model and run simulation, and then find the design space for optimal factor settings. Okay, so I may not take you through all those things in detail, but given due respect to time, we'll try to cover as much as possible. We'll also run Monte Carlo simulations. We'll try to understand, explore design space. And if time permits, I'll also talk about DOE by taking a small mixture design experiment. So let me show that. So this is the end of PowerPoint presentation. Let me get back to the jump. Okay. So I hope everybody can see my screen. So this is the data set. You can see dissolution is here. Screen size, blend time, spray rate, everything is part of it. So if you ask me, where is this data? This looks like a simple Excel field, right? JUMP is a desktop-based software. This data, if you want to use the same data as I go and explain you want to utilize the same data and explore, it is part of the example data set. So I'll show you, this is help, and you go there. There is a JUMP documentation library. Books are part of JUMP. You can go and explore the books also. Sample data library, you click it and it will take you to sample data library. Once you download JUMP, JUMP has 600 plus inbuilt data sets which you can leverage. So this is a tablet production data. You can see that this is the same data set I'm using. Or as another way to explore JUMP is, you come here, there's a statistics index, statistics scripting index, sample data. If you click sample data, it's part of help menu. The data set is categorized based on the type of analysis as well. You can see here, or as the kind of data here. And it also has teaching scripts for teaching, examples for teaching, and most of you are the professors, and in fact everyone is a professor here. So teaching scripts, interactive teaching modules, so simulations, teaching demonstrations, everything part of it. So JUMP will be helpful for researchers, scientists, and at the same time it helps the professors and students as well to learn better. Okay, so let's start with the visualization. Now this is the data set. If you have already downloaded JUMP, you can also open it up, or else if I do a little fast, the video will be available. You can always go back and refer, and then you can also exercise this. So here is the data set. Okay, you can see dissolution. There's a small header graph here. So you click here and then say, okay, what is happening with my dissolution? I can see here it is 80.2 to 64.2. That's what the dissolution looks like. Mill time, screen size is 3, 5, 4. This is a small header graph. And you can see anything below 70 is been marked as red color. That means that's a rejected lot. It just gives you some basic information about the spread and categories of and also missing value. So JUMP has a robust missing value treatment or else outlier treatment. I'll not get into that. Screening capabilities are also there. But what I would like to show is the JUMP graphical visualization capabilities. JUMP has powerful graphing capabilities, and one of them is Graph Builder. It gives you, it is under the graph menu, click Graph Builder. Okay, let me make it big. So it gives you an opportunity to visualize and explore the data the way you want, because the discovery is very important. Given the same data set to two people, they might analyze in different ways. So that's the discovery word comes into the picture. So let's get into the graph. So this is what it gives you. This is the X, Y column, X rows, group by Y, group by X. You can see rapid overlay. So the first thing is I want to check the dissolution here. Okay, so I'll just drag and drop dissolution here. It gives me a scatter plot matrix. This is how it looks like. Hey, this is fine. If these are all the controls available here within the JUMP. Now I want to see a box plot. Box plot is a powerful visual tool. I can click box plot here. Now I want a histogram here. I can click histogram here. I can see what is happening with my less than 70% as well. So this is, now I want a line graph here or a bar graph. I can click bar graph here. No, I want a little more box plot. That's fine. I'll stick onto the box plot here. And I want to see, let me put mill time, or else I want to see by screen size. I'll just take screen size and group it here. So you'll get the box plot based on the screen size here. I can easily make some observation here. You can see this, right? The screen size 5 has a lower dissolution. You can see here, this is the lower dissolution, and screen size 3 has a higher dissolution. Some kind of initial analysis. I got it, right? I'll start over here. I'll put the dissolution onto x-axis here. And I'll say I want to see based on mill time. I'll just drag and drop mill time here. It looks like there is a lower mill time is related to lower dissolution. I got some kind of observation. I'm making exploratory data analysis here. And then now that, let me take out this one here. I can put this way. So I can see, now I can add, I want to see blend time also. I can go ahead and then add blend time here. So it gives me blend time also. I'm just exploring. Mill time is below. Blend time also has a direct relationship, more or less. Not sure what is happening, but looks like it is also increasing. Let me check with the spray rate. So I'm not gone anywhere. I'm just dragging and dropping. Looks like spray time has a inverse kind of a relationship. It looks like decreasing. Let's keep that way. And I also want to see the coating viscosity. I'll drag and drop. See, all the 4 graphs I'm building here based on viscosity, spray rate, blend time, and mill time. And then if I want to see a little more on the regression, I'll go ahead and then click regression here. You can see coating viscosity has an increasing direct relationship. It has an inverse relationship. If I want to look at R square, I can see R square values here. And I can do many things here. Or you want to see a little more jitter here, you can go ahead and do jitter. At the same time, if you want to see based on the screen size, I can go ahead and then wrap it here. This is how. So now I'm gone any other platform, I was able to do a little more on the what is happening. I can change it, I can play around with it. So I was able to explore the data visually, very important thing. That's where it comes to the picture. Visualization of data is very critical. So I can add a data filter like this. I can go ahead and then I want to see by kind of, what do you call it as? Let me check with the compressor. Based on the compressor I want to add. I want to see compressor 1, what is the interaction? I want to see compressor 2, what is the interaction? If I want to save this, absolutely. You can go ahead and then save it as, export it as a PDF, HTML, interactive HTML, image. You can save it as a PowerPoint presentation or else a Word, whatever it is. Let me not show that. Now, most of the times I save it as an analysis within data set itself. So it's something I'll save the script to the data table and I'll say, go ahead. If I close this, you can see the data set. The script is saved here. I want to see what I exactly did. See, this is where I stopped here. So that's what I want to see a little more on the, I'll go the next visualization. I'll say, I want to do a little more on the heat map. So what I'll do is I'll drag and drop everything I want to see. Hey, let me not take the compressor here. Let me take this and I'll drag and drop here. So all those things gives me, let me take the dissolution here. I can get a little more on the color here and I'll click color heat map here and done. So somewhere I can understand all these 4 variables. Look at the red color. I'll change it, the gradient here, reverse the gradient here. So I want to see the red colors or the low dissolution. So look at this, anything above 70, below 70 has become red color here. So I can see with respect to blend time of 15.5 to 16.4, there are a lot of red colors. With respect to mill time here, at the same time, there's a spray rate. So I made it 4-way analysis of the data. So this is visually understanding. So most of the problems can be identified and then solved using visual approaches in any of our experiments. So this gives you the capability to do, and if I start looking at it, I can drag and drop, show the control panel here, and I can come back here and say, okay, let me drag and drop each of the cases. So this is how you start visually exploring the data. Before getting into any of the sophisticated model and simulation, visually explore the data in the beginning. Is there any kind of interconnections between the X's and Y variables? I can also do a little more here. I'll go here and then traditional scatter plot 3D, I want to say explore these three variables, I'll go on and explore here. It can give me a little more on the 3D also, you can see here. So with respect to mill time, spray rate, and blend time, what is happening to my variables? That's what I can do here. So 3D scatter plot also. So let me save this also, whatever we did. Let me save the script to local data table. Yeah, scatter plot 3D, close. So another way is, the one visual modeling approach is in plotting the y, the dissolution variable with respect to x, side by side histogram and looking at the dynamic linkage in JUMP. I'll do here, it's go to analyze, distribution, and then select all the variables here, and then click Y. I want only histogram. I'll click OK here. So it gives me histograms of all the variables. And I'll go here and let me arrange into number of rows 6. Let me make it 6 here. So this is what gives you. So now if I'm looking at this, the dissolution, and these are all the different variables and everything is. So if I'm looking at, if I want to explore, I'll select only the variables which dissolution is less than 70. So this is what the kind of a rejected lot for me, right? If anything less than 70 is not accepted, the tablet is not accepted from a dissolution standpoint. So in that case, there are some obvious clustering. You can see the clustering of defects seems to occur at high values of screen size. So if I select the high screen size 5 has a lot of defects. At the same time, with the low mill rate, you can see that. At the same way, high values of spray rate. This is the one best feature of JUMP is called dynamic linkage. Even the data gets interlinked. You can see that I've selected less than 70. The data is also interlinked here. It says 12 records have been rejected, but there could be something which is closer to that also 69.7. We can explore that further. So you start exploring that. So probably in the next stage is, hey, I want to do a little bit of test of hypothesis or ANOVA. I want to check for the distribution, or else the normality check. I can go and then check summary statistics here. I can check whatever the mean, median, mode here, median, mode, and then I click here and it gives me a lot of options on the mean, median, mode. You can see that mean is around 72. And then say if I want to check whether it is normally distributed or not, I can come here and then check for normal quantity plot. So it gives me the Lilly force region here. So more or less, it is within the normal region. That's the Lilly force region. That means the dissolution is normally distributed, but I can also go ahead and fit a distribution. It's called normal distribution. I think when it comes to reliability in pharmacy, reliability of drug, you always try to fit a distribution, right? So it gives me these two tests. You can see that Shapiro-Wilk and as well as Anderson-Darling test. And both of them says it is normally distributed. You can go and then do a test of hypothesis or else an ANOVA. I haven't changed any platform here. I think I can go ahead here and fit Y by X and I'll say dissolution here and then screen size here and then go automatically. It does a one-way ANOVA. So I can do little more here quickly. I can see that the 95% confidence levels are not matching here. You can see that there is no overlap. There is an overlap between the screen size 3 and 4, but not between 3 and 5. This is what that means. The test is significant. They're not overlapping. Yeah, in these two cases, but overall the test, it is overlapping. Then I can also do a little more on the comparing means between kind of Turkish HSD. You can see that 3 and 5 are significant, 4 and 5 are significant, 3 and 4 are not significant. So that's how you can go ahead and then explore the data also. Or else if you are a quality person, you might be teaching quality by design. You can also do a little more on the go ahead and analyze here, quality and process, build a quality control chart. Just drag and drop here quality. You can see that. So the trend dissolution, you can see the trend of dissolution indicates that the process is sometimes likely to operate closer to the threshold of failure, because the threshold of failure is 70 here, and then it's closer to the threshold of failure. So as a scientist, as a researcher, it is necessary to shift the mean dissolution a little more higher value and preferably shrink the variability around the mean to ensure all the future production of your tablets have a higher specification limit of 70, more than 70. One can also play around with a little more on the interactive process capability. I think this is something which you can always play around with. This is wonderful from JUMP perspective. So just you keep playing around the target variable and then upper control limit. You can always do this. These are the things which are possible in JUMP. Okay. So mean, sigma, you want to so you can play around this. I'll close this. Let me save this also. File. Let me get back to, and then let me save this, whatever analysis I've done within control chart builder. Save the script, data table. I'll save this. Let me close this. And this also I showed you, save the script. So now we explored this little more from a one variable perspective, right? So now that I can also do a little more multivariate. Let me close this also. I'll come here, analyze multivariate. A lot of multivariate techniques are there, including the clustering, structural equation model. Probably you might not use it, but in future, partial least square, principal components, discriminant title. So I'll just check the multivariate analysis. I'll drag and drop everything, because initially we are not building any of the models here, but we are exploring the data here. So this gives you a little more on the correlation, and then little bit on the, this is what it is, the correlation matrix, and this gives you scatter plot matrix. You can see that. The one thing which I super like in JUMP is I can also build a fit align here, and then you can take out the data points here, and then you can see a little more of shaded eclipse here. So you can see that how variables are related to each other. Mill time with respect to dissolution, there is a positive correlation. Blend time with respect to dissolution, there is a positive correlation. You can also put a little more on a vertical histogram. So this gives you a little more interactive capability, or else you can see a little more on the color maps, on the correlation. So still I'm in the exploration of data, because the more you understand in the beginning, it will be a better discovery in future. So explore the data visually. So look at this, gives you a little more correlation. I can explore multiple things here, right? So principal components, even if I don't know anything, right? And so for example, I don't know what is this scatter plot matrix is all about. I can go ahead and put a question mark here. It takes me to the internet, to the JUMP website. It says that how to interpret the result, what it is all about. So that's also possible. So let me not take out a little more time. It goes to that. So you have now explored the data from a multivariate perspective, right? So now what we can do is we can do multiple other graphical or visually aided tools in JUMP are there to explore the data. So, but due respect to time, I'll get on the modeling, regression and modeling here. Let me save this also, multivariate. Save the script. I will share the script also, the data set with all of you. Post that. So this is what, so look at this. I just dragged and dropped a question mark on that. It went through the data set or the internet, and it gave me all the details about how to go about the interpret. Let me close this. So let me get back to modeling now. Okay, so very important things. With the solution proposed by all the visual exploratory methods is an improvement, but it is limited to pairwise comparisons, one factor, one outcome. So to define a safe production environment, I'll introduce another word you are all familiar with. It's called word QBD, quality by design. So one needs to know how a set of influential factors simultaneously affect the quality of the outcome. See, pharmaceutical production faces a lot of side conditions, right, from other industries, which they do not. So there are a lot of strict requirements with respect to transparency, quality and reliability, and authorities have to approve every change. So in an attempt to give little more flexibility to pharma companies and the freedom of decision, the concept of quality by design was developed. As part of QBD paradigm, pharmaceutical quality is assured by understanding and controlling manufacturing and formulation of variables. These are the variables in the formulation we need to explore, understand, rather than a final inspection and screening out non-conforming product. We need to understand by building a model to understand the influence more formally, and that becomes a base for further analysis, or you call it as optimization. So let's understand by building the model here. Okay, so what I do is I'll go here and then see analyze. Look at this predictive model. There are a lot of algorithms within JUMP, be it support vector machine, naive Bayes model comparison, bootstrap, partition, mixed model, generalized regression as well. So, but for the sake of it, probably generalized regression is highly used now. It's called penalized ridge regression, lasso, elastic net, pretty much used in pharmacy and pharmaceutical chemistry as well. But let's build a simple model, okay, and then understand and then simulate and optimize. Okay, I'll go here, analyze, fit model. Dissolution is my y variable. I'll take all other variables and I'll put it to x, okay, and I'll run them all. This is, I'm formally establishing the relationship between x variables and my y variable here. Okay, so let's see what is happening. So it says that FX summary, that means screen size, mill size, blend time, spray rate, everything is important. Coating viscosity, but after coating viscosity, every other variable is not so significant. That means the p-value says that you can see the blue color line cut off as well. It gives me a lot other statistics which you can explore, and it gives me a prediction profiler also. I'll come to the prediction profiler. This is an important thing when it comes to predicting any of your variables here. So now that I realize that these are the 4 or 5 variables are important as an exploratory method, what I'll do is I'll select all these variables and I'll say I'll remove that and I'll rerun the model. I need not go back anywhere. I'll just say remove here. I'll select all these things. I'll say remove. Jump runs immediately, couple of seconds. It runs the model, it alters the model and say, okay, screen size, spray rate, blend time, mill time, and coating viscosity on the tablet is so critical for your dissolution. That's what it says. So now I got little information about this, right? So now the question is, I need to understand little more in depth, because a statistical model gave me only one variable. It is now that I need to understand the interaction of these variables also. What I'll do is I will go and edit this. What I'll do is I'll take this and I'll add interaction. That means I'll go here and then select factorial to degree. What it does is screen size into mill time, screen size into blend time. These are all interaction variables. I can also do one level is I can also do a response surface. That means mill time into mill time. That is a quadratic expression. So that's called response surface. I will go here and I'll put a response surface here. So it add all those variables. So now I want to see the interaction as well. So I'm fine tuning my model using response surface and as well as interaction effect. I'll just say commit here. So jump runs so quickly so that you can see that. Now the screen size, spray rate, mill time are important. Look at this, mill time multiplied by mill time is also equally important. Blend time is important. Look at the interaction, spray rate and coating viscosity combination at the same time, coating viscosity. So these are all important. What I'll do is I'll go ahead and then delete all these things. I'll remove those variables. And just on discovery mode, see, look at this, this has run, all of them are significant. And here I come, all the regression diagnostics are here, all those things. Very important. Now we'll come to prediction profiler. Okay, so profilers, before getting into the optimization, Jump has a lot of profilers, which I don't think so is there in any of your other softwares. I'll explain a little more profilers here. You can see the profiler, right? It's called prediction profiler, very powerful. It's called, there are various profilers. One of them is prediction profiler. The prediction profiler in Jump displays the conditional relationship between y and a given predictor, given the level selected of other predictors. For example, I'll show you here. Okay, so if I fix the variable screen size as 3, I'll fix this and I'll start moving mill time. What happens to my dissolution? You can visually see this, right? You can see visually what is happening to my dissolution. If I fix the mill time here and screen size at 3, if I vary the blend time, what happens to my dissolution here? You can see 75. It gives you a confidence level also. So that is where it helps. This is where the prediction profiler is so powerful. So look at this. If I keep 3 as my screen size, some of the things are the curvature in the mill time. So look at this. Initially, it increases the curvature and then automatically it decreases. Let me make it a little more big here. Okay, so you can see that. I have to play around this with little. Okay, so the curvature, you can see this, right? So the curvature is very interesting with respect to mill time here. It increases and then start decreasing it. At the same time, the interaction of spray rate and as well as I can say blend time and viscosity produce more interesting consequences. So you can see that if I keep the spray rate low, okay, at the low spray rate, the viscosity doesn't have any impact. Look at this, viscosity is almost flat. If I keep at spray rate, it doesn't have any impact on the dissolution. So visually enabling with the prediction profiler is so it explains you at a lower spray rate, coating viscosity has no effect. Blend time has a direct relationship, spray rate has an inverse relationship. Look at the confidence interval also, 95% confidence level also it shows you. So this is what it gave me now. So the expected result is little more above it. Now that you look at a 75, 70 is our cutoff. Now that the next level is Monte Carlo simulation. Statistics is always dealing with variation. Okay, it is the reason for confidence. It is the reason for the confidence intervals. The subject of statistical tests and the rationale behind all modeling efforts. I use confidence interval and statistics. So it might be unlikely that the subject matter experts will follow the process settings with such detail as to know distribution of values, including this variation in the analysis. Makes the results much more representative of the actual population that will be produced from the guest. That's why you use little more simulation in your results. So one way to explore is the Monte Carlo simulation. So here is the input parameters. So jump gives you, go ahead, first optimize the result. Okay, let me optimize the results. Desirability, I want to have maximum dissolution. Okay, so I'll go ahead and then click maximize, optimize, and I'll go ahead and then maximize my desirability. That means I want maximum dissolution. Give me the factor settings which can give me maximum dissolution. You can see here. So keep the screen size 3. It has run an algorithm. Mill time as 21, and then blend time as 17.6. Spray rate as 388, and coating viscosity at this level. And then you will get the maximum dissolution of 81.31 with a range or a confidence interval of 77 and 84, which is ranging. This is the optimized factor setting as per the data input. Now that you want to accommodate for the variation also, I said in the beginning, so you go ahead and then run a Monte Carlo simulation. I'll go and then look at the simulator here. I'll click the simulator. Now that you can change any of the distribution here, this is the best part. There are more than 20 options within random function. That's the best part about jump. You can fix it. I'll change the mill time. I'll make it random here. Look at this. You can change the distribution to normal, weighted, everything. So for the sake of it, I'll make it uniform distribution. I'll change the blend time also to fix uniform distribution. Let me change the spray rate also to uniform distribution. So I'm accommodating the results for the variation in the randomness. Okay, I'll make it random here also, and make it instead of normal. I can change anything I want, uniform distribution. So there will be some spaces you would have not tested through your experiment in pharmacy, but you can use this to extrapolate the results or test using simulation. I'll click simulate here. There's one more thing which I forgot to tell you, the noise also. So within, so factor settings and remember settings, you can always do that. You want to include the variability of the measurement process as well. Use this response noise. Okay, you can add a random noise as well, because not every measurement process will be ideal or else effective. So if you see that your process of measurement is also having issues, you can add a random noise here. So let's keep for simplicity and then say go ahead and simulate for 5,000 runs. Okay, and then okay, it ran. Looks like this is what the result looks like. This is the desirability, and then you can see this dissolution has a rate of 0.016 rate. That's the defect rate. You can see here the value. But the mean of 80 you will get, and the standard deviation of 4. That means even if the mean 80, if you make it a random uniform distribution, this is what the result is. Or else you can change the distribution, make it little more on the normal distribution. You can keep simulating the data. That's the best part about jump. You can also bootstrap You want to bootstrap this, go ahead and then bootstrap for some samples, 2005 samples, and then get the data output. So it takes a little more time. You can say 20 seconds. I'll stop them early just for the sake of it. You can see the bootstrap IDs on the dissolution defect rate here. So I can go ahead and then explore it. Or else you want to see the data, you want to simulate the data, go ahead and make a table out of it. You can further explore the simulated data with mill time of this, blended time of this, pre-array. So it gives you a lot of options. But still, you want to find the sweet spot or the most optimal factor setting. There is another profiler called surface profiler. I'll come here and I'll do a little more on the factor profiling called surface profiler. This is a response surface profiler. This is what it goes. And then you can play around with and then optimize your result here. There's another profiler which I super like, is called contour profiler. So contour profiler gives you the optimal design space. Okay, let me check this way. And I'll say I want to have multiple frames here. And I'll take the mill time and then other time on the vertical factor, and I'll go ahead and then show you this. So now this option will give you, what if you start changing? Let me add a little more on the contour grid as well. Okay, the contour grid. So what if I start looking at which is the best dissolution which I can get by playing around the finest spots using the contour profiler? That is something you can also use little more a lens kind of an approach, what you call it as crosshairs, to see, hey, what is that optimal number here? What could be the optimal factor setting? You can go ahead and explore further in detail, because the simulation will give you a result, but as a scientist, you know which are the variables are little more expensive to explore, which are the variables which are easy to control. So you have some basic understanding about the data on the process as well when you do an experiment. So this will give you an option to explore the data in depth by playing around with all these data sets. So this is the best part of JUMP. It gives you a little more extra features to play around and find a sweet spot. So look at this. If I take this as 20 mill time of this space, it gives me around 78. So I can optimize it to 79. I can play. And what happens to other variables also? You can see the sweet spot by minimizing this, how the entire contour looks like using contour profiler. So you can do this. Look at that. So these are all visually you can understand where is your optimal factor settings using your design space. Okay. So these are something I thought of showing you this. So for ease of explanation, what I've done is, with due respect to time today, I've chosen a process that has one target variable, that means your dissolution, and 5 influential factors. A similar approach can be applied using JUMP for multiple more complex analytical simulation. So the benefit of getting the freedom to further optimize the production process without the need of repeated regression of registration applications clearance clearly exceeds the effort for definition of the design space. So quality by design entities, the design space is an important component, and JUMP helps you to achieve this very quickly and efficiently, as well as visually also. So I'm just looking at the time here, and due respect to time, I'll save this and I'll show you a little more on the design of experiment. I'll just fit the model. So if I want to see what I did exactly, I'll go here and then click. It gives me all those things, whatever I just did show you. So you need not save anywhere. Unless you can simply copy paste the output also. So let me run into design of experiment for next 10 minutes. Okay, so next, and then we'll wind it up, and I'll give a little more information on the academic suite, and then we can wind that up session. So design of experiments is an integral part of quality by design for pharmacy. Okay, JUMP has a robust DOE platform. If you see as this is DOE, which enables you with not only classical textbook designs like factorial, screening designs, response surface. You can see this classical screening designs, response surface, Taguchi arrays, space filling, mixture design, etc. But also some of the advanced algorithms like designs like super saturated. You can see that special purpose, group orthogonal super saturated designs. JUMP also has a special feature called custom design, okay, which accommodates various types of factor. Let me open this, okay. Let me close this also. Close all. Yes. Okay. So, which accommodates various kind of factors, like constraints, disallowed constraints. You can specify which effects are necessary to estimate and which are desired to estimate given the number of runs. You can also specify number of runs that matches your budget for your experimental situation. So custom designs also support hard to change, easy, very hard to change factors, allowing you to construct split plot or related design. So you throw your constraints, you whatever you want to do, and you have a budget constraints, go ahead and then use the custom design. These are the cutting edge tools which are used in pharmacy industry to manufacture or else find a formulation. So I'll just take a formulation mixture design, for example. Okay, this is how JUMP design of experiments is. It has all those classical design diagnostics, custom design. I'm building a mixture design here. So one of the example I'll take is the response here is a damping. Okay, damping of the measure of electromagnetic damping of an acrylonitrile powder. So you can decide whether this is, I'll put it as, okay, damping. Okay, damping. You can see my screen. Damping. So I can maximize or minimize whatever it is at this point of time. You can choose, I'll choose none. Let's keep that way. And then I want to add 3 factors. Okay, 3 mixture factors. Look at this. I can add continuous factor, discrete, categorical, covariate, mixture. Because I'm doing mixture design, I'll use mixture factors. So it gives me 3. The first one is here. I have 3 mixture ingredients. One is the copper sulfate. Okay, CuSO4. It's a mixture, easy to change. I'll put it as 0 to 0.2 to 0.8. Okay, that is my values it can take. And the second component is my sodium thiosulfate. Okay, it is Na2 S2O3. Okay, Na2 is 2O3. With that, it is also 0.2 to 0.8. Okay. And then I'll take glycol. Okay, and then keep it as 0 to 0.6. Okay, and then I also will have a non-interested kind of categorical variables. I'll call it as 3-level non-mixture environment. Factor of interest is wavelength for me. There are 3 levels. Let me keep wavelength here. I know you might be thinking wavelength is a continuous factor. For the sake of it, let's put categorical 3 levels. And this is what I did. So I said continue here. And I can add main effects, interactions, cross. So I will say 2-level interactions. I can choose main effects or remove none. Okay, so it gives me, I can also choose power quadratic or cubic interactions. That may not be relevant in the mixture design. So 2-level interactions only. And then I'll say make a design. So it gives me, look at this. I can also, it says minimum is 12, and then you can say 18. I want to make a design out of it. Looks at it. Let it take its sweet time. Yeah, it takes 10 seconds to make a design. Let's see what it gives. Okay, so it gives me a design. So it gives me it looks like open the facts. And so let me check first what is the design is all about. Okay, so notice the smallest. Let's start with evaluation of design. Okay, so design evaluation, it gives me this one. So design evaluation, let's see power analysis. I'm not interested in power analysis. Let me see prediction variance profile. This is very important. Profiler is so important for me. So move the slider here, L1 to L2 to L3. Looks like nothing is changing. That means this is of not interest for us. That's what we decided. So one of the sliders, let's take copper sulfate here. If you start moving like this, look at the curvature here. The sliders for other 2 mixtures adjust to make the mixture ingredient sum to 1, because this is a mixture design. So you can also notice the smallest relative prediction variance occurs near the center here for the mixture factors. That's how it is positioned. The prediction variance profile, if I want to maximize my variance here, so you can see that if I maximize my variance, notice that relative prediction variance over the design space is 0.8 times the error variance for me. That's absolutely fine. So open the, let me also see a fraction of design space plot here. So what it's giving me, or the entire design space, the relative prediction is around 0.8. This is what it gives me, total 0.8. The minimum relative prediction variance is around 0.32. Look at this. This is where the 0.32 starts. It mostly centered around near the center settings for the mixture factor. So you can see that it is centered. So design diagnostics outline also you can see here. So the design is optimal relative to the D optimality criterion, even though its D efficiency is very low of 3.6 here, because mixture designs are far from orthogonal due to the mixture constraint, and that's what it does. So then typically have very low D efficiencies. The average variance of prediction is around 0.41, you can see, and this is consistent with the fraction of design space plot which we just saw. Okay, so then I want to simulate the response, make a table. I can change the weightage of this, and then it simulates the responses. In your case, you might have to go and do an experiment. Just for the sake of it, I'm simulated the response here, and then I will create a model and run a model out of it. These are all the things you get as an output. So even the prediction profiler. You can go ahead and then optimize, which I showed you just before this. The one thing is mixture profiler. This is what you will be interested in. So now that I told you how to go ahead and optimize and then see that, look at this. This is what your optimal numbers looks like. If I start moving, this is what, because we said that is can only range from 0.2 to 0.8, and then something from 0 to 0.6, the third variable. So with all this, what is the optimal space, or is the optimal design space for me? You can go ahead and simulate all these responses as well. So this is one way, or one of these is I can go ahead and show all the designs. And then JUMP has this powerful feature where you can not only understand from looking at the statistics and then the numbers, but also visually seeing the design space or whatever is the visualization of data. You can see that the crosshair, what happens here, it can range from 0.3. You can see the dissolution. Probably I have to minimize this. Let me show a little smaller here. Yeah, let me make a little smaller space so that I can see the design space also. Yeah, there you go. Yeah. So I can go ahead and then see, optimize. Again, I showed you, take an interaction profiler here. All these profilers are here, or else you can go ahead and see all this row diagnostics being Durbin-Watson test or factor FX screening, save columns. You can predict, for example, prediction formula. You can save it as, and then you can see this is what it is. Prediction formula. I can run the simulation here only, surface plot or ternary plot here. I can see the ternary plot. I'll say prediction formula here. I can run the same thing here as well, or else any of my profilers I can run here in the graphical tool also. So that's also possible. So JUMP gives you that power to go ahead into a discovery mode, and then start unearthing the patterns and then make breakthrough discoveries. So you're all faculties. Let me take last 5 minutes. So JUMP also comes with lot of teaching demonstration. I thought of showing this to you people. Sample data. If you're teaching any of your regressions, for example, so teaching scripts are available here. So if I'm teaching, for example, interactive teaching models, if I'm teaching Bayes theorem, basic statistics or regression, I can go ahead then simulate the data. For example, I can show them a little more, say, skew to right my population and have 5,000 samples I want to randomly take. Then I want to show an illustration, animate illustration. And then say, go ahead and then draw random samples. So look at this. As I click this button, even though my population is positively skewed, or else in for example, we can also assume it is unknown. I don't know the distribution of the population, but if I randomly take samples from my population and plot the sample distribution of means, it will be normally distribution. This is what assumption we make, and this is what we teach as part of central limit theorem. So if I say something is changing, people might take some time to understand. But if I show them how it is changing using interactive prediction profilers or something like this simulations, students or the researchers can also understand better. So JUMP is not only an advanced statistical discovery tool for researchers, scientists, and as well as industry, but also it has a lot of inbuilt modules which students can leverage or professors can leverage to teach better also. And that's the part of JUMP academic team we've been doing. Let me close this. So that's what so there are a lot of things as part of this. The add-ins, the textbooks are part of. If you want to learn design of experiments, the add-ins are part of it, the textbook. So design of experiments, Montgomery. So this is something which I thought of showing. The textbook is part of JUMP. That's the best part. You have an example here, chapters are here. You can go ahead and explore. These are all available on the internet. You can go ahead and explore further. So I'll leave you with that thought. I'm looking at beyond. I've already taken 5 more minutes, but I think I'll leave the my thoughts here as JUMP is a powerful visual statistical discovery software that helps researchers with its powerful interactive features so that researchers can get onto discovery mode and make breakthrough discoveries. From pharmacy perspective, it's the best tool, and that's why it is being used in industry as well as in academics. So as I said, we started JUMP academic program this year where we offer unlimited license of JUMP for academic institutions. Just please feel free to contact me over phone or email so that we can get you JUMP to your institute. And we strongly believe JUMP will be beneficial, or JUMP academic will be beneficial for professors, researchers, and students. And that's it for me. So please feel free to connect with me. And if you have any questions, you can pass it on to Professor Sucharita or the professors of management of Seven Hills School of Pharmacy. We can get in touch with you. Thank you so much, professors, for this opportunity. And thanks for everyone for spending your time, and hopefully we made it productive for you.
Yes, sir. It was a very nice presentation. Thank you so much, sir.
Should I stop sharing? I'll stop sharing. I think there was no disturbance and everybody was able to see the screen because I was on a full flow and I was going through it. Yeah.
Exactly. Perfect, sir. Perfect. Perfectly well kept, sir. No issues with that.
Okay. Thank you so much.
So can we go for question and answer session, sir?
Absolutely, madam. Yeah.
Yeah. Thank you. So Sunil, can you project the questions? Sir, we have a questions here on this.
Absolutely, ma'am. On the screen, yeah, I can. I can't. So, is this software is also available for 32-bit operating system? That's a very great question. We starting from 15th version, we don't have 32-bit operating system because JUMP has advanced visualization, which I told you. I think we stopped 32-bit. It doesn't work with 32-bit. If you would have downloaded and tried to install on a 32-bit, it doesn't work. It has to minimum has to be 64-bit. Earlier versions had, but we don't leverage the earlier versions. I'm extremely sorry. 32-bit operating systems doesn't work. I'm extremely sorry on that. So because now even our mobiles have upgraded, I think we request the professors to go a little more on the upgraded computers or laptop. So 32-bit is little challenging because you saw the visualization, 3-dimensional and dynamic linkage and all. So 32 bits doesn't support most of the advanced algorithms from a visualization standpoint. And it doesn't support the latest version. The old versions had 32-bit capability. Now the latest 15.1 is what is currently running. It doesn't support. But both Mac and Windows it supports, man. How much is effective this software when the results goes to wet lab research? Can you throw a little more light on what you call as wet lab research when you say that, Professor? Is it on, probably I might have to understand there could be some terminology which I may not be aware of it.
Yes, what the works we are doing in our laboratories, especially in academia, sir.
Academics, this is the #1 tool. That's the reason I said 600+ universities across the globe use it. And top 95, if you take top 200 universities, especially in the science and pharmacy, chemical industry, petrochemical, apart from industry I'm talking, they all leverages. You might use it for teaching basic ANOVAs, or regression, design of experiments, quality by design. And you want to start an experiment, you want to design an experiment in the beginning, probably you might have multiple factors, covariate design, all those things. So you use JUMP to optimize your design expenses, or else optimize your overall experimental results, keeping in mind the budget and all these things. You can use it for teaching also. So pretty much, I think if I look at the universities, they use a flip model where students also get their laptop to the school, and then you start teaching with them, because this is the cutting edge. That's what the industry is using, and that's what we want as part of academic program, is to collaborate with universities and help them give the licenses, and then help them run workshops for you, and then so that you can also faculties can learn, and then professors can teach better, researchers can research better, and students can also learn better. And that's the reason we are making it unlimited licenses as well. Yeah, you can see that JUMP is number one in that perspective. So you can take out the doubt in your mind, from your mind. 30-day freely available. Don't worry about the price. We are here to help you out. We are not here to make money from academics, because that's as they said, we want to collaborate with universities. Please connect with me. We can always look out, find a way for you to get, because it's not about the software. How can we collaborate with you as well to understand your need of your institute, and then customize some of the offerings or as the trainings for students. And that's how we are thinking about it. So feel free to connect with us, Professor. It's as good as giving free. Let me put that word. It's absolutely, instead of not charging a single rupees, just we want to understand whether you are ready to take up this, and then we strongly believe that it will be useful. So we can always connect on that. Don't worry about that. Yeah. So in the flyer also, I think you can drop a mail. I can share my email address and phone number. Yeah.
Yes, sir. Actually, it was a very great session. I think we have end up with a question and answer session, as it was a very clear. Maybe participants also didn't get much questions, it seems.
So there could be other way also. Okay.
Actually, it was a very lively session, sir. I can say that.
Okay. Thank you so much.
So much for, yes, sir. I think. So one more question is there, a recent question, like
how much is this useful for chemistry people? Okay, if you look at the website of Royal Society of Chemists, RSC, okay, RSC, Royal Society of Chemists, or the chemistry world, and most of you are the members of that, and then you people subscribe. Recently, with the help of JUMP, we ran a webinar called Teaching DOE. I think design of experiments is the number one skill or the focus area for chemistry coming in future. That's what Royal Society RSC also mentioned through survey from industries. So they expect graduates to learn design of experiments and then how to analyze the data. Statistical thinking is no more a specialized skill, and JUMP is predominantly a number one player in that area where majority of the people use for research. And RSC is associated. We do have something called Center for Doctoral Training, CDT, okay, through JUMP and Imperial College of London. That's a RSC collaboration. They have done it, and then through which, especially the researchers need to understand this, the doctoral program when they run. So all these research scholars need to have access to JUMP, at the same time understand the nitty-gritties of design of experiments. There's a latest book also I can share that, which is by Doug Montgomery and Brad Jones, which is called Advanced Design of Experiments, or the Modern Methods to Design of Experiments. And chemistry, absolutely, you people deal with experiments and experimental data, and JUMP will be very, very helpful for chemistry people who are working, because our customers, if you look at BASF, Dow Chemicals, all these people use JMP for their statistical discovery.
Yes, sir. Sorry, one more question is there, sir.
Sure, Professor. I can go ahead. Drug delivery research. I said JUMP has JUMP Clinicals and JUMP Genomics. As we speak, some of our leading customers like AstraZeneca, I said, right? They've been using JUMP Clinicals and JUMP Genomics when it comes to drug discovery process also. So it is pretty much useful. So starting from basic design of experiments or as basic visualization, you might do t-test, ANOVAs, or as non-parametric test, as well as you want to compare. There's a mixed model, random effects, fixed effects model. I didn't spoke about lot many things which are part of JUMP. So those are all available in JUMP so that you can leverage that to quickly do your analysis. And then let's get on to discovery. What's a drag and drop tool? You all saw that, right? So it is very much effective in that area as well.
Okay, sir. Thank you so much, sir. I think I'm now handling to Dr. Principal Niranjan Babu, sir. Thank you, sir. Sir, please unmute your mic. Yes, sir. Thank you, sir.
Namaste. Thank you for your thought-provoking and well-presented session. The webinar was very important for everyone, and it is very informative and excellent. Once again, I like to thank honorable chief guests, respected resource persons of all 3 days, especially first day, Dr. Gautam Rajan. Second day, it was with Dr. Rajkumar sir. Third day, today, Dr. Muralidhara Anandamurthy garu. Principals, teachers, my dear students, on behalf of the entire institute, I would like to thank everyone who are involved in this. Especially, I want to thank our Sutics department. I thank everyone present here from bottom of my heart. I would like to thank you again, make this event a success. I hope you will show the same enthusiasm in future webinar conducted by our college. Have a nice day. Jai Hind.
Thank you, sir. Thanks a lot. With all your support, we will do further and we will do the best in future days also. Thank you. We need your support and your blessings in your future. I'm expecting the same too from you, sir.
Yeah.
Thank you, sir. Thank you so much.
Madam, thank you so much for you and Professor Niranjan sir for giving me this wonderful opportunity. So you can give me feedback. I know I had multiple objectives and I was about to go for hours and hours. I curtailed myself. I know I've taken up other sessions. That's part of something we are thinking about the workshop for students and then doctoral and how can we enable them, empower them with JUMP. That's something which I'm excited with the plan. So hopefully we'll connect on that front and then we'll continue to have this collaboration.
Yeah, thank you so much, sir. We need your collaboration in our future
Absolutely.
academic as well as research areas, which is organized from our college, sir.
Absolutely, madam. Absolutely.
Yeah. Just can you please tell about the way how we are organized this e-FDP program?
Yeah, I think I was first thing honestly let me tell you. I think we are not on live right here now. Are we on live?
We are in live, sir. It's
okay.
live.
So honestly, let me tell you that if that is the case, you people have done a wonderful job starting from the way conceptualizing overall thing and then coordinating with the professors. And I felt very happy that I was invited and thanks to your management and the overall the planning behind it and then understanding, giving the requirements, what you look at. I think from a strategic perspective, your institution is very much clear on what you want to achieve and then what you want to achieve through academics, spreading the knowledge. Those are the things. And then overall organizing, the event is kind of flawless, smooth execution. I saw the pain you took from the beginning, testing everything, because doing online is always a challenge. And then we are all learning this new normal in current days. So the credit goes to your team. I think there are a few people who might be in the background who've been working throughout the last couple of weeks. And I sincerely thank them and great show, I would say. And then keep this up, and then you'll continue to collaborate. And then you can, if this is the kind of success you're looking at, if this is the flawless execution, I don't see any problem in running a workshop through this online also. Everybody can download a JUMP and then be not only JUMP, any kind of stuff, workshops you can easily run. And this is the planning goes in behind. And then the credit goes to your team. Just have some idli sambar after the show and coffee as well.
Thank you, sir. Thank you, sir. The only intention behind creating this e-FDP program is the teaching fraternity should get update with all the technologies which is available, and also we should make some wonders with the skills what we have already.
Agree with
So
you.
always we need to fine tune our skills, and always we need to update our knowledge so that we can able to stand our place in pharmaceutical research. That's the intention where we created this e-FDP program, especially in association with the APTA state branch there actually.
Absolutely. I think teachers are the front runners. I think if you get upgraded with the latest and the greatest of what is happening in the current world, probably that gets trickled down to your next level. That's being your research scholars and students. And I think that's the best part. I teach to learn and learn to teach. That's what my professor keeps telling me. I think that's the best way to learn from people and mutually share the information and then enrich ourselves. I know we are all going through this tough situation, but this is one of the best ways to leverage our time and learn. Yeah, thanks for that organizing.
Yeah, thank you so much, sir. Sir, Sunil sir.
Thank you.
Sir, Niranjan sir, just wait a minute, sir. Sunil sir.
Yes, ma'am.
Yeah, can we have our chief guest in backstage?
Yeah, no, Bhaskar Reddy sir is there, ma'am.
Yeah, please invite him.
Yes, thank you.
Yeah. Invite ma, please invite. Sir, good afternoon, sir. Bhaskar sir.
Very good
Nice to see you, and I welcome you.
Mr. Reddy, sir.
Namaste, sir.
Nice to see you. I welcome you for this valedictory section, sir.
Thank you.
Okay, sir. So I now request my colleague, Mrs. Divya, to introduce our today's speaker, Dr. Bhaskar Reddy, sir, to the teaching fraternity and to share the skills what the sir decides in this professional career. So I request my colleague Divya.
Good afternoon and a warm welcome to all of you. I must congratulate for this extremely well organized e-FDP program, and I again welcome for this valedictory function of 3-day e-FDP on in silico tools for biopharmaceutics and virtual pharmacokinetics. Over the last 2 days, we have had deep insights into several issues of virtual bioequivalence, and we focused on the statistical thinking. Now we have with you Dr. K. Bhaskar Reddy Garu. Who else could have been a better and a more appropriate speaker at this valedictory session? Your presence, sir, indeed a source of great motivation. Dr. Bhaskar Reddy Garu is an alumni of Kakatiya University and currently holds a position of director in Sri Venkateshwara Group of Educational Institutions, Chittoor, and he has received a grants worth 218.119 lakhs from various funding agencies like DST, AICTE, and he has received an Young Scientist Award from DST New Delhi. He is a member, Scientist Expert Committee for Functional Foods, Nutraceuticals, Dietetic Products, other similar products by FFSAI New Delhi Government of India. And he is a member, NAC Assessor Panel Health Sciences, and he is an expert member in Monitoring Committee of Drugs and Pharmaceutical Research, DST. And he is a fellow of Association of Biotechnology and Pharmacy. He has received a travel grant by DST to attend FIP in Brazil 2006. And he is an Inspector of Pharmacy Council of India. He is published 90 research papers in peer-reviewed journals, and he reviewed 1 patent. And I extremely welcome you, sir, and I feel honored and privileged for your presence today here, sir. Thank you very much.
Thank you, Divya, for your nice introduction.
Thank you.
I now request Dr. Bhaskar Reddy, sir, to give the wishes and blessings to our e-FDP program in valedictory. Thank you, sir. It's over.
Thank you very much, Dr. Sucharita. Respected correspondent, Mrs. M. Muralidhara garu, respected principal, my well-wisher, and my very good friend, Dr. M. Niranjan Babu garu, respected director, and my good friend, Dr. V. Umamaheshwar Rao garu, and convener and IQAC coordinator, and my student, Dr. P. Sucharita garu, principals, directors, and faculties, students, research scholars from various pharmacy institutions attending this program. A very good afternoon to you all, and namaste. First of all, I would like to thank the management, principal and staff of Seven Hills College of Pharmacy for inviting me as a chief guest for this valedictory function of the 3-day e-faculty development program on in silico tools for biopharmaceutics and virtual pharmacokinetics, which is organized in association with APTA AP State Branch. This is an important topic in silico tools in biopharmaceutics and pharmacokinetics. And this is an important topic, and it is a need of the hour in the field of drug discovery and drug development to hit the pharmaceutical quality. Why the simulation tools in biopharmaceutics and pharmacokinetics? Since its introduction more than 40 years ago, molecular dynamics simulation has been used in many different research fields. This confluence of recent advances in methodology is to accurately represent physicochemical input parameters with a deeper knowledge of physiological conditions in the gastrointestinal tract. More sophisticated simulation software has enabled one to construct mathematical models based on biopharmaceutical science fundamentals that are predictive of in vivo results. In pharmaceutics, in silico modeling has been used effectively to assess the need for particle size control and active pharmaceutical ingredient form comparisons to aid the API selection process for phase 1 clinical trials. The examples illustrate the pharmaceutics-based risk associated with the API and offer insights into the anticipated outcome from clinical studies. The increasing demand for personalized medicine necessitates the production of easily customizable dosage forms. As a number of possible dosage forms may scale toward infinity, their uniqueness requires a versatile production platform and numerical simulation in order to be manufactured efficiently. So the mathematical description of these systems is the only feasible approach to manage such diverse properties of different products. So these sessions, all these 3 days, were handled by eminent professors and industry personnel from reputed institutions and industry, like Dr. K. Gaudamarajan, Professor and Head from JSS College of Pharmacy, Dr. Rajkumar from USP Limited, Mumbai, and today's speaker, Mr. Muralidhara Anandamurthy. So we had eminent speakers over here for the past 3 days, and I hope this FDP has proved to be an eye-opening session for beginner and middle school researchers, and also aimed at imparting the skills required to handle different tools and technologies that are useful during the entire process of research and scholarly communications. The FDP intended to orient participants towards developing their own research plans, paying due attention to every stage of research. As a researcher, I would like to say for all the faculties and researchers, make research as your passion. Don't do it only to get a certificate or a job or to get high academic performance index score to get do it to make your career more interesting. Select only one specific topic, continue working on with it with new technologies forever. As technology changes, don't change your topic. Just modify your way of doing experiments as per new technology. Today, we can witness a number of webinars, e-FDP, conferences, and e-workshops online. Once, I would like to say one thing, which I learned from attending a conference. I think the time has come for that. One person said, 5 A's of a learning. 5 A's of a learning. Literally. He says, in times to come, first A, anybody can learn. First A is anybody can learn. Second A, anybody can learn anything. Anybody can learn anything. Anything is the second A. So this means that I am learning about artificial intelligence. I'm learning about machine learning. I'm learning about brain. I'm learning neuroscience and etc. It is nothing to do with my current job, but I learn anything. And the third A is anybody can learn anything anywhere. You can learn from anywhere. You can learn from your home, from your village, or wherever you want, you can learn. That is third A. The fourth A is anybody can learn anything, anywhere, anytime. There is no time. You can learn anything, anywhere, anytime. And the fifth A is anybody can learn anything, anywhere, anytime, or on any device. Anybody can learn anything, anywhere, anytime, on any device. That person was telling that a day will come. Today, when I look back, I think the day has come. Today, anybody can learn anything, anywhere, anytime, on any device. So with this, I would like to end by congratulating the principal of Seven Hills College of Pharmacy. When I congratulate the principal, it means I congratulate the whole team of Seven Hills College of Pharmacy for successfully conducting this 3-day e-FDP. See, as I have been watching Seven Hills College of Pharmacy from close quarters for the past at least 10 years. This Seven Hills College of Pharmacy was established in the year 2007, and it is accredited by NAC A grade. As far as my knowledge is concerned, in the JNTU region, JNTU region, or JNTU affiliated colleges, and this is the first college to get accredited by NAC A. I think I do not know. I think Seven Hills is the first college to get accredited by NAC A grade, so which is something special. And I know I have seen from close quarters about the development and growth of the Seven Hills College of Pharmacy. So I really appreciate the hard work by the management. And it is also an autonomous institute now. So it is the second autonomous institute in our Rayalaseema region. So that itself is something great achievement. Congratulations, sir, Dr. Niranjan Babu sir and his team. And with this, I wish and pray, Lord Balaji, that Seven Hills College of Pharmacy one day becomes Seven Hills Institute of Higher Education and Research, deemed to be university. I wish, and it will happen very soon, maybe 5 years or 10 years, we do not know, but it will happen. I once again thank the organizers for giving me an opportunity to be part of this valedictory program, and I thank each and every one of the organizers for giving me this opportunity. Thank you very much.
Thank you, sir. Thank you, sir. Honor to have you here. It was such a nice valedictory address from your side. Niranjan sir, we have our Professor R. Ravindra sir in our screen. So can we take R. Ravindra sir?
Yeah. You can take wishes from here.
Yeah.
From him.
Thank you, sir. Ravindra sir, good morning, sir. Can you hear me, sir?
Ravindra sir.
Ravindra sir, please share your words with us, sir, on this e-FDP. You are invited. Hello, sir. Am I audible, sir? Sir, am I audible, sir? Ravindra sir? Sir, Niranjan sir, try to convey some message to Ravindra sir, sir. Probably the voice is not audible, it seems, sir. So I can engage with the rest of the session, sir.
Yeah, you can proceed with Dr. Gautam Rajan is the other side. Meantime, I'll
Yeah,
contact
yeah,
with
exactly.
I'll come back to you.
Yes, sir. Thank you, sir. Thank you, sir. Gautam Rajan, sir, I welcome you for the valedictory session, sir.
Yeah,
Thank you.
Thank you so much.
You're in, yeah, you're invited.
Successfully people completed, I think so. So
Yes,
basic
correct,
from
sir.
my session starts and end with the application. No, there is a Muralidhara given complete package, I think so.
Yes.
Yes,
So
sir.
yeah,
Exactly.
intermediately Rajakumar given practical experience, what exactly happening in industry. Am I right?
Yes, sir.
I
Yes, sir.
feel
Very good. Okay, sir.
Muralidhar, you can extend it to all academic institution because this is the need of the day.
Thank you,
So you
sir.
can extend that your support such a manner that people understand the basic phenomena, design of experiment to artificial intelligence. Am I right? In silico methodology.
Absolutely.
So what I'm trying to say, next time I connect you soon, maybe within a week or maximum couple of weeks, I'll connect you. We'll make it one bigger platform. So we can make it a little bit publicity about how this particular in silico and statistical approach, for design of experiment as well as formulation development, research oriented this thing, not financial commitments. We'll see that we can propaganda this particular platform, to the student side across the country.
No issues, sir.
So
No issues.
yeah, that I can make it. We can associate it with one or two institution. We can make it such a platform. We'll see that how it is possible. Come to the point of this particular session, because most of the institution here and there, the people they started DOA, design of experiment, and some people they organize such a manner that no only this thing, biopharmacokinetic stimulation and the simulation and the biosimulations point of view. But only 7 Hill College organized such a manner that is a full package, I think so. That is a basic phenomena, start from A to Z packaging, I think so. I feel even most of the people they are accepting, most of the participants they given such a feedback. Because start from my part, that is a basic phenomena, how to start this particular in silico to biostimulation. And Rajakumar given what exactly happening in industry side, especially the bioequivalence stimulation, virtual bioequivalence and bioavailability, and how academician can understand. Will start from the in silico and statistical approach design, that given by Muralidhara. I feel overall this particular session is very nice, and I feel most of the people, at least 100+ people, initiated and maybe enlightened such a manner that why don't we start rather wet laboratory? We can start at least on the screen, do some research. So COVID is not a preventive matter, am I right? So research
Yes.
supposed to be continuously, we can work on the screen. So that is outcomes and the take-home message from this particular FDP program, I think so. So in these few word, my best wishes. We'll see once again other platform. We can discuss about more on in advanced technique in formulation development. Thank you. My best wishes to all the team and as well as Niranjan Babu sir. Thank you.
Yeah, thank you, sir. Please stay in the meeting. We have a bit of token of appreciation for you. So
Okay,
please
ma.
kindly accept our
Thank you, ma. Thank you so much.
sir. Thank you, sir. Thank you, sir. Rajkumar, sir. Rajkumar, sir.
Good morning, madam. Good morning, madam.
Yeah, good morning, sir. Good morning, sir. Your live, sir. Just please convey the details and your perspective on e-FDP, sir.
Good morning, all. First of all, I would like to thank management, principal, and organizing committee members of this virtual FTP program. And what I mean to say is that there is a lot of expectations from academic institutions to nourish and to train students in upcoming areas such as in silico methods, machine learning, and artificial intelligence. However, these are all lucrative and fancy technologies. The utilization of these technologies, in silico technologies, including the computational science application in pharmaceutical industry, still experts are feeling in the nascent stage. However, the basic fundamental science remains same. The fundamental science is very, very important for building any big, technology. So, what is my take-home message to the participants and faculty members, those who are here, is you people should concentrate more on the basic science, basic pharmaceutical science, without any verticalization. You should have a horizontal understanding of the science from from physical, chemical, pharmaceutical, engineering, and biological aspects. And over the period of time, you people may catch up the requirement of computational science, because when you want to do some 5 experimentation, it is not absolutely necessary of the any software which are very expensive. But the day will come, probably you required a day you have to run more than 100 experiments or 200 simulations. Then the absolute requirement of the in silico will be in place. So this is the right time. We, including me, Gautamarajan sir, and all, last 15 years, we are continuously working for development of the in silico, not only in silico biopharmaceutics. The another very gray area and very interesting area is in silico pharmaceutics. That means there are a number of companies were tried in 1980 at the at the maturation of the artificial intelligence. However, in India, especially in generic pharmaceutical industry, we are very nascent stage in silico pharmaceutics and as well as in silico biopharmaceutics. So this seminar is the basic platform wherein people were introduced different the different level of in silico methods in biopharmaceutics. This will give you a platform or the beginning opening gate, that eye-opening session for most of the faculty members, those who are really interested to build their career, maybe next 20 years from the down the line, to start their thought process. This may be the beginning point. Once again, I congratulate principal, staff members, and management committee of Seven Hills College of Pharmacy, Tirupati. And I would like to extend my special thanks to Suchitra madam, Gautamarajan sir, and principal sir. Thank you very much.
Thank you, sir. Thank you, sir. And one quote is that Dr. Gautamarajan sir is the driving force behind this conducting 3-day e-FDP program. And sir, suggestions, sir, ideas worked out well in executing this 3-day FDP program. My sincere thanks, sir. I need your help and support in future academics also, as well as in research.
No, that is a thing. I'll record one more thing in front of Niranjan. That is my college. That is a thing. Always I take a little bit extra advantages. So my colleges, because I know that beginning, the first brick where we started, I associated with Niranjan Bab. Any extreme, I can say that any help I can do it, any developmental activity with associated with Niranjan. Thank you so much, ma. This I would like to place the record in this great opportunity forum. Thank you.
Thank you, sir. Thank you, sir. Thank you. Niranjan, sir, want to share anything?
You want to present certificates over here, or maybe you want to wind up this?
No, sir. Now we are presenting, sir. Sunil, can you project the certificate? So I'm requesting all the chief guests and the speakers. Few things we couldn't able to be done because of these unprecedented situations, but kindly accept our token of acknowledgement through virtually, sir. So here is we are saying a thank note to Gautamarajan sir, and kindly accept this certificate of appreciation from our Central College of Pharmacy.
Yeah.
Sir.
Thank you so much, ma. I received virtual certification. Thank you so much, ma.
Thank you, sir.
Thank you. Good luck.
Thank you, sir.
Thank you, sir. Thank you, sir. And now I request Rajkumar Bhaskar Reddy sir, today's chief guest for valedictory session. And also Dr. Rajkumar sir. Sir, please kindly accept our token of appreciation virtually.
To Bhaskar Reddy sir.
Thank you, madam.
Thank you, sir. Thank you, sir. Thank you. And Muralidhara sir. Yeah, here is a token of appreciation from Town Hills College of Pharmacy. Kindly accept it virtually, sir. We couldn't able to do it
I'm blessed,
informally.
madam. I'm blessed. Thank you so much. Yeah.
Thank you, thank you, thank you. Thank you to all the chief guests for accepting our invite and attending this 3-day e-FDP program. I hope you will extend your support in future webinars as well as future academic works. And I request Niranjan sir to close this 3-day e-FDP program. Sir, your
Thank you.
beautiful words.
Thank you. Jai Hind.
And my sincere request to all the participants, teaching is one part of the teacher and learning is other part of a teacher. And always now it is skill India, not talented India. We are turning towards a skill India. So I request all the delegates and teaching fraternity, practice. Practice, practice, practice. Practice makes we the perfect, and keep on updating the skills, keep on updating the knowledge, so that you must be in the best place. And future, we all the teaching fraternity, we must be as a chief guest or a panel members or a speakers in our future webinars or future e-FDPs. So this is the only motivating idea for me to conduct this e-FDP program. I hope it reaches you. I hope it will give a best knowledge to you for your pharmacy education, and e-certificates will be issued to all the respected delegates within a couple of days. Thank you for joining into this 3-day e-FDP program. I also thank Dr. Deval Rao sir for extending his support and associating with Town Hills College of Pharmacy to conduct this 3-day e-FDP. Thank you all the speakers and also chief guests. Thank you very much. Thank you from Town Hills College of Pharmacy. Thanks a lot.
Thank you. Thank you. Thank you. Thank you. Bye.
Thank you, sir.
Thank you.
So much.
Thank you. Thank you.
Thank you. Thank you, sir. Bhaskar sir, for joining. Thank you. Call you back, sir. Thank you. And also I thank Sunil. It couldn't be possible without you. Sunil, it couldn't be possible without you. Thank you for picking my call round the clock. I disturbed